Mini Lab Rats. Today we're going to be looking at two different water-based experiments that are really, really cool. So we're gonna do the first one now. Here's what you're gonna need. Sharp pencils. They can be graphite or colored pencils. I'm gonna be using kind of both. You're gonna need a Ziploc bag and get, I would say, a pretty large one, either quart-sized or gallon-sized, and water. Okay, so what we're gonna do is we're gonna get our gallon bag right here. We're gonna fill it up with water. I'd say we're gonna fill it maybe about halfway up, maybe a little less. And then we're gonna seal it tightly. Okay, now it might seem really weird because clearly we're gonna be sending these sharp pencils through the bag. So what would we assume would happen? More than likely, we'd immediately think that the water will go bursting from the spots where the pencil goes through, and water's just gonna come pouring out of it, right? So let's see what happens. What you're gonna do is you're gonna take one of your sharp pencils and come a little closer and watch what happens. You're gonna push it through one side and then out the other side. Oh, look at that. No spillage. No water's coming out. But why? And how? Well, that's because the molecules that make up the bag. So a Ziploc bag is made of what's called polymer, and the definition of that is a substance that has a molecular structure consisting chiefly or entirely of a large number of similar units bonded together, meaning the example is like many synthetic and synthetic organic materials used as plastics and resin, which is what a Ziploc bag is made of. And that means that when a pencil goes through the side of the bag like this, the molecules that actually make up the bag seal around the pencil as it pushes through each side. Isn't that cool? So that means that it is a leak-proof bag. Okay, so come a little closer. And so what we're gonna do first is we're gonna put our jars in a circle. And then what we'll do next is we're gonna take our water and we're gonna fill our jars up pretty close to the top. All right, and so make sure that you fill up every other one. And so in each of the jars that has water, we're going to take red, blue, and yellow food coloring, and we're going to put it in the jars with water. Now, if you'll notice, the colors I'm putting in here are what are called primary colors. So these are the three colors that are in our sight color spectrum, and they are the three colors that make up the other three colors of the rainbow, which are orange, green, and purple. So we're gonna put all of that in there. Gonna let them get nice and mixed. All right, and so your next step is you're gonna take your paper towel and you're gonna fold it in half 2 times. So we're gonna fold this way and fold this way so that you have long strips of paper, and you're going to need 6. And so what you'll do is you'll gently place one end in the jar. And if you watch, the water's already starting to come up. And so you're gonna keep doing that, where one end goes in an empty jar, and one end goes in a jar of water. All right, and if you're already watching, you can see here in my yellow and some in my red and my blue, the paper towels are already pulling up the water and taking them all the way over. What this experiment is called is walking water or walking color. So what's gonna happen is the water is gonna go from the jar with the water to the empty jars from all three colors, and they're going to combine into those three colors that I was talking about earlier, orange, green, and blue. So then you get to have a walking rainbow. How cool is that? Now remember, these experiments that we did today are easy and you can do them at home with stuff that you have at home. And as always, if you do, show us what you've done and tag the Bedford Public Library because we'd love to see what you're doing at home.